Right, what I'd like to do is another motion map, something a little more complicated this time. We're going to create a motion map from data. I've got some data down here already, time and position. Again, the time units aren't important. They're typically seconds, but they're the first time unit, the second time unit, etc. And then my positions are 1 unit of measure, 2 units of measure, and so on. You can call them, centimeters, meters, whatever is appropriate. Same thing with the time. It could be 1/10 of a second, 2/10 of a second, or it could be 1 full second or 2 full seconds. Again, whatever's appropriate. So what we want to do is go ahead and lay out our motion map. Again, it's a number line with a start, and we'll just go ahead and put in some hash marks to indicate where each unit of measure is, unit of distance. So what I want to do is start at 0. At time 0, my object is at 0. So I'm going to go ahead and label that so I don't forget where I started. Time equals 0 right there. At 1 time unit later, I'm 1 distance unit along. 2 seconds, I'm 2 distance units along. At 3 seconds, I'm 3 distance units along. At 4 seconds, I'm at 4 distance units along. At 5 seconds, I'm still at 4. So what we do to show that it's staying in the same position, rather than putting the dots right on top of each other, what we do is we stack them above each other. At 5 seconds, I am still at, oops, that was 5 seconds, I believe. You know what? I should label this up. I'm losing track. So this is 1 second, 2 seconds, 3 seconds, 4 seconds. So that makes this 5 seconds. And then the next one's going to be at 6 seconds, so I'm still at 4. And then at 7 seconds, I'm back to 2. So at 7 seconds, I'm here. Again, rather than dropping this down, I just go at a different level to keep track of what's happening at each second. And then at 8 seconds, I'm back at 0. So let me finish labeling this up. This is at 6 seconds. This is at 7 seconds. This is at 8 seconds. All right, to continue on with my motion map, what I will do is put in my velocity vectors. These are all evenly spaced, so again, evenly spaced equals constant velocity. So what I want to do is I want to make sure that each one of these velocity vectors for this is the same length. So to get from this spot to this spot, it definitely had to have some sort of velocity. It had to be moving, so we'll give it some velocity in that direction. And again, I'm going to make that the same length because I'm evenly spaced throughout here. Once I get to here, this is stopped. To get from this position to this position, it has no velocity. It does not move. So I don't need a velocity vector for this. Same thing here. To go from here to here, it's in the same position. No velocity vector here. To go from here to here, it definitely had to be moving. And it's moving faster than it was on the way out because that spacing is greater. So what we'll do is we'll give it a greater velocity vector, a longer arrow, and now it's headed back towards the origin. Same thing with this. Now the spacing after that is even, so what I want to do is make sure that those velocity vectors are the same length. And we don't know what's going on here. We're just going to assume that it's continuing on with the same motion that it had been. So I'm going to go ahead and put another velocity vector on that, the same length as these. Yeah, same length as these. So a couple of things I want to point out. We already talked about evenly spaced equals constant velocity, so we want to make sure those velocity arrows, those velocity vectors, are the same length. At a standstill, standing still, we stack the dots. Because we're staying in the same position. In words, what this object is doing is we can see that it's moving away at a slow speed. So I may want to label this with away, slow, steady. I think typically what I've been doing is going slow, steady away, given speed first. So let's do that. Label this as slow, steady. Remember, steady indicates constant velocity. Slow, steady, and then the direction here is away. So that's the first part of the motion. Then it stands still. Then it moves fast, but steady. It's still at a constant velocity towards. Motion map for a little more complicated motion. And we created that from this data.